what are some of the biggest challenges in providing connectivity to remote areas, and how can satellite constellations help bridge the digital divide? So this is the first question, and I think we can start again with Astrid first, and then get a couple words, a couple sentences from each of the panelists.
Okay, thanks, Niklas. Very, very interesting question. Of course, I think today satellite technology is the only seamless technology existing today that gives a global coverage worldwide, depending on terrestrial networks. So comparing to terrestrial networks, of course, the biggest challenge today to bring connectivity worldwide is the cost of the infrastructure, comparing very often to the number of inhabitants in certain zones. So let's say the pricing is too expensive to roll out worldwide. That is one of the main challenges for people to bring connectivity worldwide. And another topic, of course, is what we call roaming issues. As soon as you have cross-border applications, means that there need to be agreements, which are most of the time complicated. And of course, most of the time, I say very often, we're all speaking about connectivity. But if you look at the globe today, there's only 15% of the world today covered by terrestrial and telecom networks. So that's leaving a huge part of the world without any connectivity.
Perfect, thank you, Astrid. So, Swarnayoti, you can add again from your side as well, from your perspective.
Oh yeah, sure, definitely. As there is the very important aspect that she has said about the implement of physical infrastructures, which is really sometimes there is a lack of doing it. There is also deployment of for the non-terrestrial networks, sometimes to moving towards the remote regions and all the aspects where the fiber optics cannot go there. Because if you see, there is, as an example, on the Asia Pacific region, there are multiple areas, there are billions of people are way far from the connectivity regions, even if they are not near to the fiber optics. So giving them a chances to coming to the on the coming connectivity regions, the satellites can really help on those matters to to close the gap. And another main aspect is the accessibility, and next is the affordability, which is most important for this kind of service.
Perfect. So thank you, Swarnayoti. So hi, Karina, again, and thank you again for joining us at such a late hour in Germany. And maybe you can speak a few sentences about Clio Connect's constellation and how your constellation can help provide connectivity and bridge the digital divide.
So Clio Connect is, as you said, based in Berlin, Germany. We are launching the constellation of up to 600 satellites in space, LEO satellites, and we will provide with a broadband internet in the world. So, and concerning like challenges in the remote areas, the developing countries don't have really good terrestrial infrastructure, and it takes a lot of time to deploy these infrastructures. That's why satellite connectivity can be just in time and in place. And it's there, and it's much faster to actually deploy satellites in this area, and it can provide these developing countries actually with a better access to education and many more benefits. So the biggest challenge for terrestrial networks, as I said before, is this time and also economic considerations.
Perfect, thank you. So Mark, this time to you again, the spotlight. So can you also briefly introduce yourself again, and then share your perspective from Kratos's perspective as well on this issue? I think you're currently on mute, Mark. Mark, yes, I think now you're fine. Perfect.
Thank you, Nicholas. Mark Klinger from Kratos Communications. We're a ground station or ground infrastructure company. We do everything on the ground, and that's kind of, I'd like to expand on what Astrid said earlier. The cost of infrastructure is one of the key things, but it's also the complexity of the infrastructure. A lot of the ground stations today still require an installer to go out and install a VSAT and to point it and call back to the station. That all needs to be automated. We've seen it with Starlink, where it's fully automated, just like you would work with your cable modem in your house. That needs to be pushed out throughout all the different constellations to lower the overall cost of delivering service. To me, that's one of the biggest challenges.
Perfect, thank you. So now moving on to Gianmarco, and the second question that I have, which is from your perspective, Gianmarco, and from again what Capgemini Engineering is so far again seeing, what are some of the key factors that satellite constellation operators need to consider when planning for optimal coverage and connectivity, and how are these factors evolving over time?
Yeah, I see my video. Thank you for having me. I see my video is a little bit blurred. I hope it's not the same for you guys. So I'm John from.
Yes, so I think you have the option to
Just my
remove the
nephew.
background from your side. Sorry to interrupt. Just to make sure that we can see you as well. Yeah, I think I've removed it from you now.
There you go.
Perfect. Yes.
Yeah,
we can
thank you.
see now.
So thank you for having us. I'm John. I'm from Capgemini Engineering. So we are a service engineering company. And when we look to answer your question, it's interesting because when we look at the key problems that companies are facing, whether it is for enabling global coverage worldwide, but at the same time, we look at how can we prepare for the future. And we consider that the connectivity provided by LEO satellite is great, and it is really enabling us to reach the unconnected and connect, desert, rural, or very hard to reach areas. But when we look at what the future is going, and especially when we look at how can we really enable internet coverage everywhere, we consider that there's a lot of there's more data coming into play, and therefore satellite communication itself is not really the sole key for the future of internet coverage, global coverage, right? And one way that we solve this problem, or that we look into it, is really how can we embed to an existing LEO satellite constellation or communication system 5G and technologies that are highly suitable for highly automated and fleet of autonomous systems. And that is true because it enables us to connect the air to the ground, but at the same time enable us to prepare the future of what is going to be the next connected battle space, or connected aerial vehicles that include autonomous drones and high altitude platforms. So this really is our point of view, is to try to figure out how can we combine what is the connectivity provided by satellite and space vehicles with what is on the ground. And we really see a very sweet spot in combining the benefit of 5G is one of the technologies, or like ground-enabled technologies that enable high speed and low latency connectivity with what is existing in space. And so we are really placing between the two, and how do we connect it? And that is really in line with our future vision of what we call the connected battle space, or connected airspace, which is not only just in air, but even in the ground and on space.
Perfect. So thank you, Gianmarco, again for providing us with the key factors, and again the vision that the Capgemini has, and how you are helping the companies in planning ahead for those factors to make sure that all the operations are going well, and their constellation is working as intended. So my next question will be here to Hiro, which is as the demand for low latency, high bandwidth communications growth, how are the satellite constellation operators addressing the need for improved data processing and management?
All right, yeah. Thank you for the question. So yeah, just brief introduction of me again, and I'm from Warp Space. Warp Space is like a service provider utilizing the optical laser comm by relaying the data from medium Earth orbit, especially for like Earth observation industry and like space stations. To answer your question, well, so in terms of operation, it's a lot different from radio frequency. Optical communication laser comm is point to point, and we have very specific operations compared to RF, especially like satellite maneuver and also tracking and the capture of the laser length. So that's actually we develop ourselves as well. And in terms of say like a cyber security and also data processing, we don't really do satellite data processing on our spacecraft. just because we work with several different Earth observation operators, which include optical sensors, synthetic aperture radars, hyperspectral RF. We can't really do various satellite data, satellite imagery processing on spacecraft. It's too complicated. But we do have certain, cyber security encryption of ourselves, so that, even though a laser is much safer than RF, we try to put extra securities. And also, one just additional things to note is that when we would when we want to employ QKD, quantum key distribution, Lasercom has much more compatibility with Lasercom, and QKD works well with optical rather than RF. So that's another things we are considering. Yeah.
Thank you, Hiro. And maybe Mark, you could again comment from the RF perspective on the same question, which is again how are so basically when the with the increasing as the demand low latency, high bandwidth communications grows, how are satellite operators addressing the need for improved data processing and management from the RF perspective?
Yeah, what we're seeing is a big shift, as I mentioned earlier, to automation and orchestration, as well as software-defined radios. This allows a lot of flexibility in the infrastructure. We've heard about software-defined satellites. Once you have the ability to have once you have a software-defined satellite, software-defined ground, then you have a ton of flexibility to change on demand. A lot of applications don't require low latency, but they require a high bandwidth. So having multi-orbit constellations also help a lot in organizing the data as well as the management. So in summary, having orchestration and software-defined radios, software-defined satellites with multi-orbit constellations.
Perfect, thank you. And my next question is, what role can partnerships and collaborations play in enabling satellite constellation operators to expand their capabilities and reach those new markets? As Astrid was saying, that over 75%, no, 85% is not really being covered. So how can the collaborations play a role in that and expanding this coverage? Yeah, sure, go ahead.
I can take the question if you want. So today, Kinis, as a satellite operator, LEO satellite operator, operating the 9 satellites and having 25 extra satellites coming up by the end of this year. We are closely looking at collaborations with telecom operators. We try to say that independently of the technology, what the customer wants is this data, and this is really independent of the technology that is in the back. So today, Kinis, we have collaborations ongoing with people like Orange, Vodafone, Deutsche Telekom, Telefonica, because they have IoT platforms, and they are working on our technologies like cellular technology or NB-IoT or LoRa networks. Which have limitations in coverage, which have limitations in with roaming issues, and their end customers are most of the time very big groups that have an international positioning, and they want their data from end to end. So today we have already signed agreements with different telecommunication operators, but we also signed agreements with terrestrial operators to offer to the end customer the best of each technology. And I think this is really, we should not position all of us only by ourselves, but find this kind of agreements, because in the end, the customer wants the data and he doesn't care which technology is in the background of getting his data. So this is really one of our key strategies, and we move really fast because the telcos, they really have, I think, a need for combining their terrestrial networks with satellite technology.
So it's really all about, again, collaborating to increase the added value to the end user, right?
Yes.
So that's a very important point.
And it's also by making the technology easier. So recently we've integrated with ST Engineering with an off-the-shelf STM32WL hardware, which means this hardware can have a stack, terrestrial stack and satellite stack. So it's compatible with LoRa, it's compatible with Sigfox technology, it's compatible with a satellite stack. That means that any integrator with an off-the-shelf electronics hardware can communicate with Kinis Constellation.
Perfect, thank you. Karina, again, so now a question to you, as your company is planning to add 600 satellite constellation, as you discussed. So how are some of the, again, regulatory challenges that you are facing? What are those regulatory challenges, such as spectrum allocation and licensing, and what impact could this have on the future of the industry? So that's a question to you, Karina.
Yeah, that's quite a complicated question.
Yes, I know, and we're going to get input of all the panelists on that one.
Yeah, so everybody probably heard about the 3GPP release 17 of 2022, right? So where they're talking about combining actually terrestrial and non-terrestrial networks. This is quite important. And we see also a lot of development. I can see there in satellite direct and direct to device services. So for example, some LEO constellations like SpaceX partnered with T-Mobile, Apple with Globalstar. We see it in the, happening in the market. So these are one of the most recent regulations. Also, I saw the news that FCC recently proposed rules for a new regulatory framework for satellite to smartphone services. They call it as supplemented coverage from space. So it's also a quite important release for satellite industry. And I would say these are two trends that are kind of in the space right now. So this.
Perfect. Thank you. Thank you. So Swarnayoti, you can go ahead and expand on the question if you'd like.
Well, yeah, sure. I mean, for our company, Apogeo Space, so we are basically building satellites which is size of 0.3 EU. I mean, literally, you can put it in your pocket. And so with that technology, so we are trying to put it the more affordability to the customers, the end users. But from a spectrum's point of view, that we are using kind of free spectrum. So we are not going to sell our own product, so the customer has a huge varieties of options, so they can buy a specific product with that frequency and they can put it in their system. But also there are, I think that there are a couple of options of the frequency spectrum can be utilized for IoT project, can be as a dynamic spectrum leasing, which is really important for when you have the high charge for the spectrum, but you just give the payment the time you use for a particular portion, and that is you can decrease the cost and you can give more affordability to your customers when you have the high capex on development of your system. But there is also other cases such as the fractional channel leasing for a global connectivity and ground station support. I think that there are a couple of things can be done to give more affordable for the end users.
Perfect, thank you. So maybe Astrid would also like to comment on that question as well.
On the regulatory part?
Yes, yes, regulatory and licensing and spectrum
and licensing. That's definitely one of the key points, and we have two full-time people dedicated to this topic. I think, Niklas, you have met Asia of our company during the conference as well. So it's not an easy topic, and I think with the mega constellations, with the announcements of direct-to-device applications, that there is definitely something that's ongoing also is the positioning of the big actors on the different licensings and frequencies. And there is a very, very big job in the back of all our constellations of negotiations between the different operators of these constellations. Because at some stage you can see there will be a lack of positioning, a lack of capacity, and I think this is really one of the key strategic points of all constellations, is the negotiations between the different constellations of the capacity. And this is a huge job. Since Kinis, for example, we operate from end to end. So we position our own regulatory licenses on the different frequencies. We have the Constellation, we have our own ground stations. We have 20 ground stations worldwide, which we operate ourselves. So we don't only negotiate on the uplink, but also on the downlink, and on the licenses that allow us to operate our ground stations in the different countries. So it's a major job, and I think there will definitely be some tensions on the licenses coming up with all these different constellations that are going to be launched.
Thank you. And I see Gianmarco is also raising his hand.
Yeah, I had a question for Astrid, or in general on that topic, because when we look at the utilization of satellites, we see an interest from the defense players. You mentioned different players, and we see an interest from the defense player to be capable of, specifically for the affordability, but there is a huge satellite market driven by commercial sector, and we're seeing the defense sector that is looking into how can we reuse those hardwares to provide secure communication for in the field to our troops and to people on the ground as well as in the air. What is your position, your point of view when we look at secure real-time data informations? If we are to consider ourselves in a scenario where there is a same hardware or a set of similar hardware, a constellation which is shared between defense or like governmental players and commercial sector, which might be companies that you mentioned or that are looking to provide internet overall worldwide.
Yeah. Yes, and I can speak for the European defense sector, especially because you can now see with the different geopolitical issues since the start of the war between Russia and Ukraine that this topic has even increased, and there are some major topics ongoing also by the European Commission by the willingness of launch a European constellation, which has, of course, two roles. First role, European sovereignty, but also commercial applications. What we see on the defense sector is that, yes, the defense is keen of using the same devices for commercial applications and defense applications. They use, what they want is dual opportunities. But the security layers to use the same devices or the same infrastructure is different. So there are different encryption layers depending on the commercial application and the defense applications, of course.
Perfect. So I think that answers Marco's question. Yes, perfect. All right, perfect. So now the next question, which is really again the core of the panel, which is reaching the unconnected, and now we're going to talk literally about the places that are unconnected, which are some of the developing regions out there. So how can satellite constellations solve that issue of connecting those developing regions that are unconnected? And what are some of the strategies for the companies to really expand their reach to those regions? Because those are the regions that need the connectivity the most, right? Which sometimes we see that it's tougher for companies to enter those markets, and it's just the cost of acquisition of, again, clients in those regions is also tougher. So how can that be, solved, and what are the strategies for overcoming that issue? And whoever would like to go ahead first.
May I speak in that case?
Sure, here, go ahead.
My opinion, yeah. So as a workspace, we do Lasercom. So I think we are talking about the direct to consumer business of Satcom, and the several the operators who do that, such as like SpaceX, but they usually provide antennas, dedicated antenna for the users, and those one way, and also their discussion of direct to cell. It's a really big topic. I was at satellite last week as well, but everybody's talking about regulation of this of this direct to cell. Those are also one way, but I think unconnected area, more specifically probably around say Africa. We work with African companies there as well, so that we provide some backbone capability using the Lasercom, so that certain areas they have absolutely no network. We can provide very high speed, like 10 gig, 100 gig. It's like equivalent to say submersible cable capability through space network that could be only done by laser. That's one thing we think. Yeah, and I think we need several different nodes to provide network to those areas because the application is different, and also like a cost per terminal per user also varies depending on the area. So users have to choose which kind of infrastructure they want to use. Yeah.
Perfect, thank you. And there was one of the previous speakers again. I don't remember exactly which speaker that was in the previous days, but he mentioned that pretty much majority, 60–70% of the industry is communication geared, and communication geared. So how do you see again the role of the competition playing part in again connecting all the regions and again expanding the reach of the connectivity? And maybe Mark could go with that first.
It's interesting because you've got the traditional satellite operators who have been struggling for years to get a low-cost flat panel antenna. Now we've had Starlink out for a couple of years with a relatively small, low-cost antenna. And then we also have Kuiper coming out with their 7-inch satellite antenna. To reach the unconnected, it's going to be tough for the terrestrial operators because they need to come up with a low cost, really small, flexible antenna that can be on multiple orbits to compete with those other two, LEO constellations. Otherwise, they're going to be relegated to backhaul, where you've got a local base station that's collecting 5G signals and backhauling them over larger links.
Perfect, thank you. And for the less maybe aware and more general audience that is listening to this, so what would be the main core differences between again LEO constellations and the GEO satellites that are providing the telecommunications and connectivity? So who would like to go ahead with that? I see everybody is giving everybody else the spotlight. So I think Hiro is raising the hand, or maybe I didn't see. No.
I think. Oh yeah, Hiro, please.
Sure, Swarnayori, yeah, go ahead.
I spoke already, so yeah, go ahead.
Okay, no, I mean the point on that on the GEO and LEO on the mostly it comes on the return on investment at some point, because to development of the GEO and still it takes as a return of investment is still higher than LEO from the current state point. But now how the LEO is increasing from the business point of view, and which is creating more business opportunity, more application opportunity, which is creating more business aspects in the LEO. But there is also, from a technical standpoint, is that there is a multiple beam from satellites. If you have a LEO, so you are focusing only the particular area of an Earth. So you need so many satellites to have a full global coverage. But for GEO, you are literally covering the half part of the world at a single time. So, but on the other side, if you have to make a proper trade-off between the latency, the GEO has latency around 477 milliseconds, somewhere around, but now the latency is decreasing for the LEO. And latency increasing more the demand in the market. Increasing demand in the market means that there will be more supply to the market, and which is generating more players, which is generating more customers, and which is also creating more business opportunity for Starlinks, OneWeb, and so on.
Perfect. Thank you, Swarnayori. So now for the next question, again, I want to take this panel a bit more to the telecommunications applications, and as satellite constellations become more prevalent, what impact could they have on existing industries and infrastructure such as aviation and terrestrial communications, telecommunications? So that's a question.
So maybe I can take this question.
Sure, go ahead, Karina.
Also, I want to add a little bit about our constellation and comparison to GEO constellation. So our LEO constellation will have a throughput of 10 gigabytes per satellite per second. And if you multiply it with 300 satellites or 600 satellites, I can tell you, like, it would be a lot of capacity, and that's a huge advantage. And also, as another panelist said, yes, LEO Constellation have lower latency, so roughly 30-40 milliseconds. And this is where we're aiming to, and plus inter-satellite links. So it will bring a lot of capacity on Earth, and would be great to combine terrestrial networks with non-terrestrial and have a better internet in every point of the world. So coming to the question, so what was the question, just to say?
Yeah, so the question was for the aviation and terrestrial telecommunication applications.
Yeah, so as for aviation, passengers will have an ability to be connected during the whole time when they are flying from one point to another. So they can actually play games, stream YouTube, or have Netflix movies there on board.
So no more boring flights, basically, that's what you're saying.
No more boring flights, and also all employees would be connected actually all the time, so there would be no excuse that I'm on the flight, so we all should work when we are flying.
Well, I'm not sure we're so happy about that part.
Yeah, so the connection would be the same as actually while we are using on the ground. So this is the development for aviation industry. And for terrestrial networks, I can go to the Sahara Desert and I can connect from any point of Sahara Desert using, I don't know, any telecom provider, because telecom provider would partner with LEO Constellation or any other constellations, and will have this internet as this capacity from any point of the world. So it will be possible to be connected everywhere. That's a beautiful future that we are trying to reach.
Yes, perfect. And as you're mentioning, being connected everywhere, now as we're looking out for the, again, lunar activities and the lunar economy and lunar infrastructure being developed, and also on the lookout for the Mars missions. So what would be the proper ways and, again, the strategies that constellations can help us also to enable communication with those places as well?
I'd like to have a go.
Sure. Go ahead.
Because we already work with NASA JAXA for like cislunar communication as well, feasibility study basis. But I think for any communications for Artemis plan, it's called LunarNet, as I think most of you are already aware. And they are already conceptual, say, visuals. So each kind of node, they already specified what frequency they are planning to use. And out of those, mostly like X, S, Ka, as you know, they're not too different from the previous deep space mission. But optical communication is already mentioned. It's very close to a Space Development Agency standard. I would say 1,550 nanometers also. But those, I think, will be the kind of the standard for commercial companies to consider. I guess. And well, because I think government should take a lead for this cislunar communications because it's complicated, and each company have to be compatible to each other, and the government should look after basically which direction every companies are going. So that's gonna be probably the way. So that's about it from me, but probably other people have some opinion on that as well.
Mm-hmm. Perfect. Yeah. So anyone can chime in, whoever wants to add to that.
Yeah, I mean, our point of view is really, I mean, it's really a combination of different technologies, because what Karina just mentioned on, the end of boring or low connectivity in flights, that's definitely something that we can achieve with LEOs, and is interesting. But when we look at really a future where we see a highly automated system and highly automation that is taking over simple operations from autonomous driving on the ground, from autonomous flying, and at the same time that will enable usage of, let's say, robots, of autonomous systems that are exchanging data in real time. And those kind of data usually are much more volume-wise intensive than what we exchange for SMS or to reach in the unconnected. So our point of view is really a combination of those two things. When we look at the African or developing countries, let's say, where you need quick access, at least a first level of access to internet, this is where LEO is primarily bringing the solution. When we look at the future of connected airspace and systems, we really see a combination of those two, which I think it goes in line with what Astrid was saying earlier.
But as for autonomous driving, I want to add that it's important to combine their terrestrial and non-terrestrial, because we talked with with a lot of actually automotive companies in Germany, and they need this antenna that can catch both connections, because, for example, for urban areas, it's quite hard for LEO constellations to reach. So, I mean, it's better to use 5G networks there. So it's important to have this hybrid antenna that can actually jump from one to another. Yeah.
So I think we spoke a lot of applications that are on Earth in urban or rural areas, but there's a huge part of the world to be covered with satellite technology also for oceans and sea. And we speak about flight technology. But you also have a big advantage with LEO constellations on what we called AIS, Automatic Identification System, which is a mandatory system on all the vessels worldwide, where LEO constellations really bring a big difference as well, because they can solve a major issue that is currently existing on very dense areas, for example, Southeast Asia or the Mediterranean. So there's also a big part to be covered on the different oceans and on the vessel management of the oceans.
Perfect, thank you, Astrid. And again, as we've seen during some of the other panels as well, like 40 minutes always seems to be not enough to really get fully into the subject. So and for the summary again for this panel and some of the key takeaways that we have had, right? So how do we see in the next 5 to 10 years the communications and connectivity industry and market playing out, and what will be some of the developments that we will see with the new technologies, let's say, for example, artificial intelligence, that will be playing part again in that. So we can get a couple sentences from each panelist on that, and then we can include the panel as well. So we can start maybe from Gianmarco.
Yeah, sure. I mean, as I said, future is going to be more connected, more fun, and we're going to have connectivity everywhere. And I see a big potential for what is the application on highly autonomous systems of these 4G, 5G non-terrestrial networks.
Perfect, thank you. So Karina?
So as I mentioned before, aviation, we would be connected, and we can have internet there, we can stream, we can play games. We can also be connected from any point of the world. And also I like this concept of smart factories, where you can control your factory from any distance, or smart city also, and also smart shipping, when you can put some sensors on when you can actually track your parcels, for example. Yeah, so the world would be connected, and it would be interesting to see how we would be able to have internet everywhere.
Perfect. So Mark?
Yeah, we're going to see a telco satellite convergence. There's MEF carrier Ethernet that's already on the market. There's the TM form getting involved. There's 5G, NTN. All these things are going to create something we haven't seen in satellite before, which is interoperability between vendors as we move to a more software-defined world. Orchestrated automation systems like Kratos's OpenSpace will allow vendors to talk to each other, and that will drive down costs across the board, including the constellations going up, driving the bandwidth down. All of that will converge into a much more seamless and cost-effective solution for connectivity.
Perfect. Thank you. So Hiro?
Yeah, well, definitely the world is gonna be more connected as we have a vision of making connected space. A space layer will be utilized for communication for sure. And I think we see the trend of doing SATCOM shifting from Geo to say LEO or MEO and change, basically adding the frequency, including optical. That's what we observe. Definitely that's gonna revolutionize or change the way how we use our network on the ground and more resilience, I think.
Swarna Ayoti?
Oh yeah, definitely. I mean, as we all agree on that point about the connectivity. So from a IoT company perspective, that is also one of the goals that what we are trying to cover up, but as well as giving the enough value for the customer. So as you said, to making the automations of the data and putting the proper, I don't know, cloud processings or any kind of processings with the machine learning AI, maybe in future, that can automate the process and make the data more valuable for the customers and for the end users. That is the goal for everyone.
Wonderful. And Astrid?
Okay, so instead of speaking about connecting Mars or the moon, I think let's take already care of the 85% of the Earth that has no coverage and leaving people without technology today. And for me, the key argument of the future technology is, I think the key of the success is a network of networks combining technologies.